Our first question today focuses on perplexity. What does lower perplexity indicate? Let's look at the options. A. Worse model performance. B. Better model performance. C. Overfitting. Or D. Underfitting. The correct answer is B. Better model performance. We choose this answer because perplexity measures uncertainty, and when a model is less uncertain or confused, it performs better. Lower numbers mean higher confidence. Now, let's understand the complete definition. Perplexity measures how confused a language model is when predicting the next word. It's calculated as 2 raised to the power of cross-entropy loss. Lower perplexity means the model is more confident and accurate in its predictions. In simple terms, it's a confusion meter for AI. Think of perplexity like a student's confidence level during an exam. A perplexed student hesitates between multiple answers, while a confident student knows exactly what to write. Lower perplexity equals higher confidence equals better performance. Basically, less confusion means better results. Here's a real example with actual values. If Model A has perplexity of 25 and Model B has perplexity of 15, Model B is better. This means Model B is on average choosing between 15 equally likely words, while Model A is choosing between 25. Like having a GPS that's 60% more certain about directions. Lower numbers win. Remember this. Perplexity equals puzzlement. Lower puzzlement equals better performance. Think backwards. Less puzzle, more performance. Our next question examines BLEU score. What does BLEU primarily measure? The options are A. Semantic similarity, B. N-gram overlap, C. Syntactic correctness, or D. Fluency. The correct answer is B. N-gram overlap. We select this because BLEU specifically counts matching word sequences between machine output and reference text, not meaning or grammar quality. Let me read the complete definition. BLEU, which stands for Bilingual Evaluation Understudy, measures how many word sequences called n-grams match between machine-generated text and reference translations. It combines 1 gram, 2 gram, 3 gram, and 4 gram precision scores with a brevity penalty. Simply put, it's a word-matching scorecard. The layman explanation is this. BLEU is like comparing 2 essays to see how many identical phrases they share. It counts matching single words, word pairs, triplets, and 4-word sequences. More matches equals higher score equals better translation quality. It's essentially a phrase-matching game. Here's a practical example with real values. Reference text. The cat sat on the mat. Translation A. A cat sat on the mat gets BLEU approximately 0.75. Translation B. Cat sit mat on gets BLEU approximately 0.35. Translation A scores higher because it shares more word sequences with the reference, like a student getting 75% versus 35% on matching exercises. Higher overlap wins. The memory tip is BLEU equals blueprint evaluation understudy. It checks if your translation follows the blueprint. Think blueprint matching. Our next question covers few-shot evaluation. In few-shot evaluation, how many examples are typically provided? Your choices are A. 0, B. 1 to 10, C. 50 to 100, or D. 1,000 plus. The correct answer is B. 1 to 10 examples. We choose this because few-shot specifically means learning from very limited examples, typically between 1 and 10, not 0 or hundreds. Here's the complete definition and importance. Few-shot evaluation tests a model's ability to understand and perform new tasks with only a handful of examples. It measures how quickly AI can adapt to new situations without extensive training, mimicking human-like learning efficiency. In essence, it's rapid learning assessment. The layman explanation goes like this. Imagine showing someone just 3 examples of how to solve a new type of puzzle, then asking them to solve 10 more similar puzzles. Few-shot evaluation tests if AI can learn patterns from minimal examples, like a quick learner who gets it immediately. It's about instant pattern recognition. Real example with values. Show AI 5 examples. Happy leads to happy emoji. Sad leads to sad emoji. Angry leads to angry emoji. Excited leads to party emoji. Confused leads to dizzy emoji. Then test. Surprised leads to what? Expected. Surprise emoji. If the model gets 85% correct on 100 new emotion-to-emoji pairs, it demonstrates excellent few-shot learning ability. Quick learning, high accuracy. Remember, few-shot equals quick-shot learning. Like a basketball player who needs only a few practice shots to master a new technique. Think quick mastery. Our next question addresses human evaluation. What is the main challenge with human evaluation of LLM outputs? The options are A. Cost and scalability, B. Technical complexity, C. Lack of metrics, or D. Model limitations. The correct answer is A. Cost and scalability. We select this because while human evaluation provides the highest quality assessment, it's extremely expensive and time-consuming to scale up for large datasets. Let me read the complete definition and explain its gold standard status. Human evaluation involves real people assessing AI outputs for quality, relevance, safety, and usefulness. It's considered the gold standard because humans can judge nuances like creativity, appropriateness, and emotional intelligence that automated metrics miss. Humans catch what machines cannot. The layman explanation is straightforward. It's like having professional food critics taste every dish versus using a machine to analyze ingredients. Humans can detect subtleties, context, and quality that no automated system can fully capture. But hiring critics for every meal would be impossibly expensive. Quality costs money. Here's a real example with actual values. Evaluating 10,000 AI responses costs. Automated metrics cost $10 and take 1 hour. Human evaluation costs $15,000 with 3 experts at $5 per response and takes 2 weeks. This is why companies use hybrid approaches, automated screening plus human validation for critical outputs. Perfect but pricey. The memory tip: human evaluation equals gold standard, but gold costs. Perfect quality, expensive price. Think premium evaluation. Our last question focuses on benchmark datasets. Which benchmark is commonly used for general language understanding? Your options are A. ImageNet, B. GLUE/SuperGLUE, C. COCO, or D. Squad only. The correct answer is B. GLUE/SuperGLUE. We choose this because GLUE and SuperGLUE are specifically designed as comprehensive language understanding benchmarks, while the others focus on images or specific tasks. Here's the complete definition and role. Benchmark datasets are standardized collections of tasks and data used to evaluate and compare different AI models fairly. They serve as universal testing grounds where researchers can measure progress and rank model performance across the entire field. They're the universal report cards. The layman explanation is clear. Think of benchmarks like standardized tests such as SAT or GRE for AI models. Just as students across the world take the same test to compare abilities, AI models are tested on the same datasets to see which performs best. It's the Olympics of artificial intelligence. Fair competition for all. Real example with values. GLUE contains 9 tasks testing different skills. Sentiment analysis. This movie rocks. Leads to positive with 95% accuracy. Question answering. Where is Paris? Leads to France with 88% accuracy. Text similarity gets rated 0 to 5 with correlation 0.85. Top models achieve 90% plus overall GLUE score, like getting an A+ on the AI intelligence test. High scores rule. Remember this. Benchmark equals best mark competition. Where AI models compete for the highest score. Think championship scoring.